Hello, I'm Jonathan Smith, and today I'm going to go over basic alternator 101 training. Here we have the components that go into an alternator. The belt drive, which is a belt that's hooked to the crank pulley. You have the stator that's fixed. The rotor spins on the slip ring with the brushes, and the current goes into the rectifier, is controlled by the regulator, taking current to the batteries. There are two basic mounting configurations. There's a J180 style, which is most commonly used previous to the 90s. Up to the mid-90s, used the J180 style. And when that was used, the alternator was the tensioner. So the top of the alternator went to an arm, you pulled that across. When the belt had a certain amount of tension, you tighten that up, and that gave you your belt tension. There are two types. There's a tall hinge and a short hinge. Leece-Neville had the tall hinge, and then our competitor, when they came out with their J180 alternator, it was a shorter hinge. It was 3/4 of an inch shorter. Most of the time, when you put this alternator on, the top arm can compensate for the tall hinge and the short hinge. But the last few years of J180 mount, International DT 466, 530, 570 had a fixed J180 mount. So they were using J180 mount with a belt tensioner. So since it's fixed, if a tall hinge alternator comes on it, you have to put that back in. And if short hinge alternator comes on there, that's the alternator that you have to use to replace it because there's no adjustment. The second alternator mounting style is a pad mount alternator. This style was developed in the late 90s to address severe vibration issues that came on with the introduction of the Detroit 60 series engine. It incorporates 4 bolts that mount the alternator directly to the engine block. There are 2 sets of holes to accommodate wider and narrower pad mount configuration. This greatly reduces the vibration felt by the alternator to deliver a longer alternator service life. Alternators come in 2 basic configurations. There's a brushed alternator and a brushless alternator. A brushed alternator has 2 carbon brushes that glide on a slip ring to conduct the current to the rectifier. Some of the advantages of a brushed alternator is they're easier to put together. You have the rotor goes through to the stator. You have a single air gap. The single air gap enables you to have more output at low rotational speeds, and they're more cost effective. The main disadvantage to a brushed alternator is the brushes wear out. Either the carbon wears out till you get to the spring, or the carbon wears through the slip ring, and when either of those things happen, it's a catastrophic alternator failure, which will require a rebuild or a new alternator. The second configuration is a brushless alternator. So by name, you've taken out the brushes, you've taken out the wearable item in the alternator. So the next failure point in the alternator is the bearings. The advantages are reduced service parts because there's less parts inside the alternator. When you've taken out the wearable item, you usually triples the warranty. So a typical brushed unit is a 1 to 2 year warranty, where a brushless unit is usually a 3 to 4 year warranty. But that also goes into a disadvantage because that means the alternator is more money. The other main disadvantage is now you have, from a single air gap where you have your stator, a gap, and then the rotor, now you have dual air gaps. So you have your stator, you have your pull piece, and then you have the coil underneath. So you have an extra air gap in there. For each air gap, you lose some of your output ability. So the big disadvantage with the brushless alternator is typically you have less output, especially at idle. Here's your basic cutaway of the alternator construction. Front housing, rear housing. You can see this is a pad mount alternator. The rotor shaft, that's where the pulley goes on. That goes on the belt that is driven by the crank pulley. Over to the right, you'll see the rectifier, the slip ring. That's where the brushes ride on. Pull piece with the coil that turns over the stator to make your magnetic current. On the bottom right, you'll see the rectifier. That's where the diodes are. You have positive and negative diodes on a solid lead frame that conducts the current. This cutaway, basically the same parts, but this is a brushless unit, so you'll see where the coil is, and then from between the coil and the stator, you'll have the pull pieces that move. So you have your fixed portion in there and your dual air gaps. Again, rectifier. So really the only difference here is you have a brushless unit as opposed to the previous slide with a brushed unit. Alternator, or an AC generator, creates voltage through rotating a magnetic field inside a loop conductor. AC voltage is pushed through a loop conductor that converts it to direct current, DC, as it flows through the output rectifiers. The amount of DC current produced is based on how fast the rotor is rotated by the engine and how much voltage is applied to the slip ring. So if you want to think about it as an engine produces 300 horsepower, but it's not 300 horsepower at idle. There's a power curve. Same thing with an alternator. The faster you turn the alternator, the more output that alternator produces. Then the regulator monitors and controls the alternator output voltage to a set point of 14.2, and the actual set point is 14 plus or minus 0.2 volts. So controlling the current equals changing the speed or changing the magnetic field strength. The regulator serves as a governor of the electronic system. So the regulator won't let the alternator go to 15 volts, 16 volts, 17 volts. It maintains its voltage at the 14 volts. If it's a 24 volt system, then it manages the voltage at 28 volts. Load placed on the alternator terminals, the regulator adjusts the alternator field current to the electrical load on the alternator. So the more load put on the alternator, the more the alternator will produce to cover that load. The less load on it means the alternator has to produce less, but it can only produce the amount that it is rated at that speed. What is remote sense technology? Remote sense technology is basically another way for the alternator to sense battery voltage and then make voltage accordingly. So standard alternator makes battery voltage at the B+, and it senses that through the B+ cable to the batteries. Remote sense is a line that goes directly from the alternator to the batteries to sense the true voltage of the batteries and then to tell the regulator how much voltage it needs to make to keep the batteries at 14 volts. Why do you need remote sense? Because from the cable from the alternator, the B+ on the alternators, the B+ on the battery, there are connection points. So each connection point, you can lose 1/10 of a volt. So say you have 2/10 of a volt drop in the B+ line. Remote sense will see that your alternator is making 14 volts, and then it's only getting 13.8 to the battery. So remote sense will tell the alternator you need to kick up 2/10 of a volt to make sure that you're getting a full 14 volts to the battery. So the alternator will be producing 14.2 volts, and then to the battery you'll have 14 volts. So as your line drops grow, so if you have 1/2 volt difference between the alternator and the battery, now the alternator will put out 14.5 volts to make sure that you're getting 14 volts to the battery. Is remote sense required? There are some manufacturers that use it. Freightliner, it's typically a Freightliner application that does use it, but as long as there's a line between the batteries and the alternator where the alternator can see battery voltage through that line, if your remote sense line breaks, your alternator should revert back to B+ sense, okay? And the dangers with remote sense or the troubleshooting is what it sometimes can do is it masks voltage drops in your line. So we recommend no more than 1/2 volt of voltage drop between your positive line and your negative line. But as cables get older, connection points get dirty, any of those factors will increase the voltage drop in the line. So you could potentially have an alternator that has to put out 14.6 or 14.8 or even 15 volts to make sure that it's maintaining 14 volts back to the battery. So periodically, even though you have remote sense and it's making sure that you're getting the right voltage to the battery, you want to check your voltage drops in your line to make sure that you don't have any cabling issue that you don't know about. This graphic simply shows where the remote sense line is. It goes from the small S post to the battery, and it's a direct read line to see what the alternator is producing versus what's getting to the alternator. You'll see on the red line there's 0.3 of a volt resistance. So if that's all the drop that we have in both lines, the alternator is putting out 14.3 volts to make sure that the battery is getting 14 volt to maintain the correct state of charge for a 12 volt system. So with this graphic, you'll see where the remote sense line goes from the S post on the alternator, sense, directly to the battery. There's no connection point, so it's giving you a true reading of how much current the alternator is producing and getting to the battery. With this, you'll see there's 0.3 of a volt resistance in the positive line. So the alternator is now making 14.3 volts to ensure that 14 volts is getting back to the batteries to compensate for the drop in the line. Thanks for watching this alternator training. Please stay tuned for more training videos from Press Light Leece-Neville.